Good morning, everybody. Thank you very much for the invitation, and thank you very much for the introduction. My name is Gábor Varga. I'm the Hungarian National Technology Officer of Microsoft. I was invited to this conference to talk about how Microsoft relates to GPUs, what kind of services we have based on the GPUs, and how we can leverage this great computing resource. But let me start by rewinding the time with 3 decades. And let me ask you if you can recognize these machines. A hint, none of these are computers. One of them is a communication device. It's a telex machine, which looks like a computer, but in fact it wasn't. Its purpose was only to communicate written text like in the 70s and the 80s. The other one, which is quite similar to it by appearance, it's not a computer either. It's a word processor from the time in the 80s when word processing was done by special hardware, special equipment, such as this one, Rositex from Rolitron from the 80s. And so both of these pictures were taken before the PC was invented. But then the PC came along, and the PC was successful in adopting a lot of use cases, a lot of applications, because it was much easier to deploy an application on a widely available PC platform than buying special hardware. And also, it was much easier to create an application for a PC, which was widely used anyway, as opposed to building something from scratch from integrated circuits. So there is a strong sense of convergence in the history of IT. Let me give you another example. This picture is an ATM machine. And many people probably don't recognize that even within the ATM machine, there is with high likelihood, there is a PC working inside. If there is maintenance, if there is anything that would reveal the user interface of the PC buried inside an ATM, only then you can recognize that even this very specialized financial services focused process is managed by the PC. So the machine, which used to be called a personal computer, is now increasingly inaccurately called because it has adopted a lot of use cases and it has evolved into a general computing platform. I could give you a lot more examples, for example, the smartphones, but instead of going into more examples, let me give you a trivia question. What do the cloud and the youngest British royal baby, Archie, have in common? Any guesses? What they have in common is that their names caused a lot of they caused their names skyrocketed in terms of popularity very soon after they were born. If you go back just 10 years ago, when the cloud started to gain popularity, then there were a lot of IT services already available which were not name called. But the cloud was born, and increasingly all providers, and at least many providers, started to adopt the cloud as a tagline or as a name for their service or product. But instead of going into an academic discussion about what the cloud is, let me just point out that probably the most important characteristic of the cloud for our purposes today, discussing the GPUs, is not the fact that they are not touchable. It is not that it is owned by somebody else. It is not that it's remotely deployed. But probably the most important characteristic of the computing platform called cloud is its elasticity and flexibility. And this is very often overlooked. And why this is relevant for our discussions about GPUs today is because the cloud is promising to be a similarly unified platform for all computing, just like the PC was 20 or 30 years ago. That is not to say that we will solve all computing tasks in the cloud, but my point here is that the cloud, in the true sense of the word, in the hyperscale cloud, we will tend to recognize all kinds of computing devices, whether or not it came from the traditional approach, the CPUs. One example for that is certainly the Azure cloud, the cloud service of Microsoft, where the most common computing resource is the virtual machines. Virtual machines which are based on CPUs. But there are a lot of computing resources within Azure which have GPUs. And I could go even further to add other silicon chip architectures. In addition to CPUs and GPUs, you can already find FPGAs as well. And the point here is that if we are successful in creating a unified development environment in the cloud on top of these silicon architectures, then the development community and the application developers and ultimately the users of the applications will benefit from a much bigger scale, a much bigger choice, because the developers will be free to choose either the CPU, the GPU, the FPGA, or maybe other silicon architectures to run their software on. And there is a very important point here, and let me refer back to elasticity and flexibility. The point is not that you can get a GPU or FPGA from the cloud. That would be trivial. But the point here is that you can make a decision at any point in the future that you want to trade some of your GPU resources to CPU or some of your CPU resources for GPU. So there is a very high level of flexibility, and that means that you are not required to look into the future when you make the purchase, make the decision what kind of computing platform you would like to deploy or procure for your development or your operations. So the point here is the ability to trade off. Anytime in the future, you can decide to give up some of the GPU resources and replace it with CPU or other way around. And that makes the cloud as a good candidate for the next computing platform, which includes all silicon architectures, not only the traditional CPUs. In order to achieve that, we need to recognize that there is a lot of IT infrastructure deployed out there already. In other words, the cloud has to be integrated with the on-premises infrastructure, what we call the hybrid. So when we talk about the cloud, in fact, we don't really talk about the cloud as such by itself, but we mean the hybrid of the cloud and an on-premise IT infrastructure. Later, I will come back to that, and I will give you some examples what we mean by establishing a hybrid infrastructure that benefits from the best of both worlds, both on-premises and the cloud. But before going further, let me also highlight that one of the reasons why the cloud is promising to be a the next unified computing platform is the scale. Everything depends on the scale of operations in IT. It is not only the cost. That's kind of obvious. If you buy tens of thousands of servers or storage, then the cost will go down. That's kind of obvious. But even things like security or compliance pretty much depends on the scale, because there are a lot of threat vectors in these days which just didn't exist a couple of years ago. You have to invest a lot continuously into security. So sooner or later, it will be a resource question as well. If you have the resources, if you have the budget, then you can establish and maintain a secure IT environment. If you don't have the budget, if you don't have the resources, then chances are that you will not be able to follow the latest threat vectors and defend against them. So that comes back to cloud as well, and that comes back to the scale of the cloud operation, and that's why we believe that a secure environment can be done with cloud resources more easily and more readily than with exclusively on-premises tools. I mentioned hybrid already, and that's an important point. Just one slide before going into a bit deeper technical depth. Let me explain what I mean about the hybrid. It's not just we have two infrastructures, one in the cloud and one on premises. We have virtual machines, on both sides, and we expect them to talk to each other because we provide an IP connectivity. Of course, connectivity is one aspect of being able to build a truly hybrid environment. But then the other aspect is the directory. We shouldn't expect our users to maintain two separate identities, one for the cloud and one for the on-premises infrastructure. Another aspect is the management. We shouldn't expect the operators to learn two different tool sets. All these things should be unified in order to claim that we are able to offer a truly hybrid infrastructure as opposed to a separate cloud and a separate on-premises infrastructure. And the list goes on. There are a lot of integration points which we need to support before we can claim that we can offer a truly hybrid experience. I should be upfront mentioning that Microsoft Azure is not only about Windows. Roughly half of the resources in Azure run on Linux or open source. And in case you missed the news in the past several years, Microsoft has adopted a lot of open source technologies. And there are several examples to that. We are one of the most active members of the open source community. We also joined the Linux Foundation, and one of the strongest contributors to open source projects is also Microsoft. So that means that we don't require any developer to adopt Windows if they want to work in Azure. They can, of course, it's supported. We have a tool set, as we have always had, but we have also built a tool set within Azure using open source technologies, and I will bring some examples in the later part of my presentation. So, focusing on the GPU resources within Azure, There is a broad range of GPU resources within Azure. The most visible part of that is probably the virtual machines. So you can create virtual machines within Azure which have GPU resources, typically NVIDIA chips built inside. And that enables a lot of great scenarios that probably you know very well, around not only visualization, but also simulations, not only rendering, but also artificial intelligence. So all the scenarios that the GPUs have adopted in the past, say, 20 years, since they came into existence. And of course, we also have specialized GPU resources fine-tuned for neural networks. And we also have GPUs fine-tuned and optimized for visual tasks. One of the many virtual machines that you can create in Azure is the ND version 2 virtual machines, and this is just one example. It has the V100 card from NVIDIA, and this is the most performant virtual machines in our portfolio currently. There are 8 NVIDIA cards in one virtual machines. And of course, as you can expect, and you should expect from a cloud service, you are able to very flexibly create a lot of virtual machines of this type, and the performance of the GPU resources will add up. And I will also talk about how to do that a little bit later. But in addition to the ND version 2, we also have video optimized virtual machines. The series is called NV, the NV series, which are optimized for visual tasks. And this is a summary of all GPU virtual machines. In case you are interested, you can dig into details. So much about what kind of virtual machines are available from Azure. But then, of course, you want to scale your platforms beyond one specific virtual machines. And as I mentioned, the biggest promise of the cloud is the flexibility, the elasticity, the ability to build a lot of virtual machines or other computing devices together and treat them as one logical unit to execute the applications and the jobs. There are several tools to do that within Azure, like cloud resources, what we call cloud resource. There are scale sets. There are a lot of approaches how you can multiply the power of one virtual machine. But the one that I would like to highlight to you is called Azure Batch, which is targeted as developers. So it doesn't approach the task of scaling up the resources on the infrastructure level. There are solutions to that. Azure Batch specifically is a developer-focused concept. So when you write your application and you require additional resources, probably for a limited period of time, for example, for hours or maybe days, then you can leverage the cloud resources. And if you do this through the Azure Batch, then you can offload a lot of the infrastructure and administrative tools, requirements and jobs that you need to do in order to build up and maintain and run this cluster of virtual machines. So things like authentication, things like auto-scaling, will be handled by Azure Batch. You can express a scaling rule that brings in new resources when certain conditions are met. You can also upload the input data in one go, and all the virtual machines which will be created by Azure Batch will access and will download that input data as they are executing their tasks. The main concept within Azure Batch is the pool of resources, and even the pool is a collection of virtual machines, but even the pool, it doesn't have to be created by you manually. Azure Batch does this job for you. A typical flow of invoking and using Azure Batches on this slide. So you can upload the input data in one go to Azure Storage. Then you can upload the application, the software, which will need to run on the nodes, which are members of the pool. And you can initiate the work by launching the job. The job will be broken down to tasks. The tasks will be executed in specific nodes of the pool. And the output will be collected into a unified place from where you can download. And during the execution, there is also an error handling. There is monitoring support so that you don't have to waste your precious developer time into digging deep into infrastructure, because that will be done for you by Azure Batch. And as I mentioned, there are a lot of open source tools available in Azure, and Azure Batch is no exception. You don't have to use .NET. If you would like, you can, but you can use also Python or Java in order to create your application with the help of Azure Batch. By the way, if you received this slideshow, then there are links, clickable links on several slides, and you can quickly go directly into for example, the tutorials, which are listed there. There is one specifically for Python developers, or the online training, which is also listed there, how to start developing in Azure Batch. And of course, there is container support in Azure Batch, not surprisingly, because containers are also a big phenomenon. And of course, they are supported, and there is a GitHub project how to run containers in Azure Batch. One of the applications of the GPU resources is artificial intelligence. So I thought that I add a few more slides about this application for a good reason, because I think that artificial intelligence will gain popularity in the next several years. I explained that you can run neural networks on virtual machines in Azure which have GPU resources, of course. But we didn't stop there. We have specific AI-focused development environments available from Azure, so you don't need to worry about the virtual machine layer. If you are familiar with things like TensorFlow, if you are familiar with things like Keras, or just about any popular artificial intelligence or machine learning framework or development tool, then chances are that you can run this software and development environments in Azure. There is support for Databricks, Spark. There is support for Azure. There's support for Hadoop. Just about anything which became popularity in the past couple of years. And underlying these environments, you always find a selection of silicon architectures, which is not limited to CPUs or GPUs, but also FPGAs. And by the way, FPGA, I think it's a great example how the cloud can make how cloud can help an architecture become mainstream. Because I think even though FPGAs are not a new invention, but they didn't manage to become mainstream before going into cloud services, because with the cloud services, what we can promise to you as developers is that if you have a neural network already created in TensorFlow, then you can choose an FPGA for some neural networks. So it's not for all neural networks, but some models, you can run the exact same TensorFlow network on FPGAs. Okay, so I think my time is more or less up, right? So let me stop there. The slideshow includes some specific examples how we accelerate the development of artificial intelligence with a layer, created on top of the hardware layer. But let me just fast forward to the last slide, where I included two important links. And if you have access to the slideshow later, you can create your free Azure environment to start developing GPUs, CPUs, as well as FPGAs within Azure. Thank you very much for your attention. And if there is time, I'm happy to answer questions.
Thank you very much. So thanks for this very interesting and exciting topic. So any questions? I thought the coffee was not enough.
Yes, I wanted to ask, do you have any public data on what operating systems are used on Azure in relation to HPC workloads? Like how much of the VMs are running Linux that are using GPUs, and how much of the VMs are running Windows that are using the GPUs?
I don't have statistics in that level of detail, unfortunately. But certainly, if we narrow down to HPC or supercomputing, then for sure most of the jobs are running on open source. I would like to guess how much it is, but it's an overwhelming majority of the APG workloads are on Linux. If I go more broader, including all other workloads which are running in Azure, then roughly, and again, this is just a rough estimate, roughly the ratio is 50-50. But if you are narrowed down to HPC, then most of them are Linux. If you mean which Linux distributions, okay, then there is a list of compatibility available on Azure.com, and the well-known Linux distributions are there, and it's just few of them. It's not just few of them, but several of them. So if you have your favorite distribution, then chances are you will be able to continue your work in Azure. Thank you.
Okay, thank you. Other questions? I would have a question which is related to this very last point. So does this available like freely for academic institutes, or do we have to do any kind of contracts, whatever?
Yeah, that's a very good question. Azure is free for everyone for the first $200. Plus, Azure is free. Some of the Azure resources are free for everyone for 12 months, even after you have depleted your $200 a quota. Plus, so the third option, the academic option, we have, there are two answers to that as well. We have competency centers in several Hungarian universities where we work together with the specific university to help the knowledge transfer about artificial intelligence in Azure, and through that channel we can make available, we are working on making available unlimited, or at least with a much higher limit that I mentioned. I should be very careful because we are talking about HPC, then unlimited has a very different sense as opposed
to reach the limit.
Yeah, right. So a much higher quota of Azure resources. Currently, we have 5 artificial intelligence competency centers in the country, but we plan to increase the number further. Plus, even if you don't have access to any of those competency centers, then there is an additional quota for $100 Azure every year, which you can use as a student or as a member of the faculty for just about any Azure resource. So there are, I believe, 4 or 5 different layers, $200 Azure for everyone, 12 months of some Azure services for everyone. Then if you are lucky enough to study or work at a university where we have an AI competency center, then you have a much higher quota there. Plus, you have a $100 quota personally if you are a student or a member of the faculty.
Okay, thank you very much.
Thank you very much.
Okay, any further questions? Okay, so let's thank Gábor again. Thank you.